Now we have the following properties of series which follow from our corresponding laws of limits. Suppose we have two series, the sum of an and the sum of bn, and they both converge. Then the series, the sum of an plus bn, the sum of an minus bn, and the sum of c times an, where c is a constant, they also converge. And the sum of the series with terms an plus bn converges to the sum of an plus the sum of bn. The series with terms an minus bn converges to the sum of an minus the sum of bn, and the series with terms c times an, where c is a constant, converges to c times the sum of an. Here's an example where we might use this. Suppose we want to sum the following series. It's not a geometric series directly, but it is actually the sum of two geometric series. This nth term, this formula for the nth term, we can break it up into two fractions. It's 3 over pi to the n plus 1 plus 2 to the n over pi to the n plus 1. And now we can break this up into two series using this middle rule here, and we have that the sum, this nth term, is the sum of 3 over pi to the n plus 1 plus the sum of 2 to the n over pi to the n plus 1. And now these are geometric series, and the r is less than 1, so they actually converge. So we can actually calculate this sum by calculating the sum of those two series. Well, let's look at the first one, the sum from 0 to infinity of 3 over pi to the n plus 1. We expand it to find the a and the r. A is the first term, which is 3 over pi when I plug in n equals 0 here, and r is the second term divided by the first, which is 3 over pi squared divided by 3 over pi, which is 1 over pi. So the sum of the series is 3 over pi for 1 minus 1 over pi, which is 3 over pi minus 1. And since the r is less than 1 here, of course, it converges. The other series on the right above is the sum of 2 to the n over pi to the n plus 1, where the n runs from 0 to infinity. And it is also a geometric series. I expand it to find the a and the r. The first term with n equals 0 is 1 over pi, and the second term is 2 over pi squared. And I can find the r by dividing the second term by the first, so I get r is 2 over pi, and a is 1 over pi, and the sum is 1 over pi over 1 minus 2 over pi, which is 1 over pi minus 2. And now, the sum of my original series is the sum of these two sums. It's 3 over pi minus 1 plus 1 over pi minus 2, and I can add those two fractions to get 4 pi minus 7 over pi minus 1 times pi minus 2.